April 15, 1943, marked a surprising turning point in air combat history when Major Donald Blakesley, flying a P-47 Thunderbolt, recorded the type's first victory, a plane that had been widely ridiculed and doubted. That moment was not merely the downing of a single enemy aircraft, but a vivid demonstration of a new idea of war, that concentrated firepower combined with industrial capacity could change the rules of the game. The P-47 was not born as a lightweight masterpiece or an agile turner. It sprang from a design philosophy entirely different from European tradition. Instead of squeezing every ounce of mechanical performance to optimize weight and maneuverability, American engineers, under the leadership of Alexander Cartwright, or Alexander Cartway in some records, chose another path. They put their trust in weight, armor, fuel capacity, and, most importantly, massed firepower. The result was a massive fighter by the standards of the day. A bulky fuselage, a sturdy airframe, a powerful Pratt & Whitney R2800 double-wasp engine with turbo-supercharging that allowed high power to be maintained at altitude, where many German machines began to lose performance. But what truly set the P-47 apart was not merely weight or top speed, it was the scale of its armament. 8 Browning .50 cal machine guns, 4 in each wing, each fed with large ammunition loads, up to a total of 2,800 rounds in early variants, producing a continuous wall of fire that could be fired in short, violent bursts, enough to render any target hit effectively unsalvageable almost instantly. When Blakesley squeezed the trigger from roughly 300 yards, the simultaneous volleys of the 8 guns sounded like a storm tearing through the air, and the FW-190 he targeted, armed with 2 20mm MG-151 20 cannons and 2 7.92mm MG-17 machine guns, quickly disintegrated under the dense hail of bullets. That moment was not only a personal feat, but proof of a radical change in thinking about aerial firepower. Where Luftwaffe doctrine emphasized accuracy and conservation of ammunition, operating on the belief that a few well-placed hits were enough to finish a target, the P-47 embodied the opposite philosophy: shoot a lot, shoot continuously, and create a kill zone from which the enemy could not escape. Abundant firepower was paired with technical features designed to ensure reliability. Belt feed systems and removable link ammunition feeds, and the time-proven Browning M2, durable and fully interchangeable, allowed American pilots to fire extended bursts without fear of jams or failures due to non-standard spare parts. The Germans and Luftwaffe intelligence were initially incredulous about this degree of standardization. 8 guns on a single-engine fighter seemed impossible, and when they inspected components recovered from damaged or downed aircraft, they found perfect parts interchangeability. A screw down to the smallest detail could replace the same item in any gun. This, together with ruthless mass production, created an armament system that was not only powerful but sustainable at large scale. Equally crucial were American training and logistics philosophies. P-47 pilots arrived in theater with hundreds of flight hours, including dozens to hundreds of hours of gunnery practice, and were encouraged to open fire when the chance presented itself. The oft-repeated sentiment among pilots was that you did not have to be a marksman, just aim, hold the trigger, and let the guns do the rest. Combined with the plentiful ammunition produced by U.S. factories, each P-47 turned into a weapons platform that could expend enormous quantities of rounds, a concept baffling to the Germans. While German pilots were forced to conserve each 20mm round because of limited supplies and the high value of each hit, American pilots fired liberally, creating continuous streaks in the sky. The visual effect of tracer rounds fired in high ratios made the stream of bullets look more like a continuous beam than separate projectiles. That psychological effect was significant. The mere presence of P-47s could shake enemy morale. The industrial figures made the picture even clearer, with manufacturers like Republic at Farmingdale and Evansville, and ammunition plants such as Lake City reaching tremendous output, hundreds of P-47s per month and billions of rounds per year. It became feasible to sustain heavy firepower over long periods, creating a positive feedback loop: more aircraft, more ammunition, more training, more sorties, which produced more combat experience for pilots and greater losses for the enemy. Tactically, the P-47's heavy firepower changed the approach to combat. Instead of having to seek the perfect firing angle and rely on short, precise bursts, P-47 pilots could attack from safer distances and with more flexible attack angles, because even a short burst could wreck a wing or engine. This reduced the classical advantage of light, highly maneuverable fighters that had dominated traditional dogfights. Coupled with the airframe's toughness, many P-47s returned riddled with bullet holes, yet still airworthy. The Thunderbolt demonstrated that survivability through exchanges of fire itself was a strategic advantage. A heavy, damage-tolerant airplane could bring its pilot home for repair and return to service, whereas more fragile aircraft, however nimble, were often permanently lost. The German response was not slow. As reports of the P-47's destructive capability spread, the Luftwaffe was forced to reconsider ammunition doctrine and attack tactics. They began to study weapon upgrades, increase firepower, and even develop heavier armed variants. But such changes were almost always constrained by industrial limits, fuel shortages, and time. Meanwhile, the P-47 continued to consolidate its position, not only through air victories, but also by escorting convoys and clearing the way for ground operations with heavy strafing attacks. This versatility, rooted in sheer firepower, demonstrated a truth. In modern war, firepower combined with production capacity often determines the outcome more than pure technical superiority of an individual aircraft. Looking back at the instant Major Blakesley pulled the trigger and watched an FW-190 dissolve in a column of smoke and flame, we see more than a single victory. We see a symbol of an ideological shift. The gun was not just a tool, but an industrial manifesto, a declaration that when a nation can produce weapons and ammunition at scale, it creates a new form of power in the air, a power that can melt away an enemy's isolated technical advantages.
The foundational idea behind the P-47's success did not lie in a miraculous invention on paper or a single technical secret, but in a strategic decision that set the direction. Design something that could be mass-produced, easily repaired, standardized in parts, and, most importantly, supplied without limit. At the heart of this philosophy was the belief that industrial advantage could be transformed into battlefield advantage, and that sustained battlefield dominance could crush any isolated technical efforts by the enemy. Republic Aviation, its auxiliary factories, and facilities like Lake City were not merely machine shops. They were the bloodline of modern warfare, where every screw, every belt of ammunition, and every hour of labor was organized to create a sustainable and expandable production ecosystem. Producing P-47s at rates of hundreds per month, over 400 per month at peak production, was only possible through standardized supply chains, assembly line processes, and centralized quality management. The Browning M2s on each wing were manufactured to such precise specifications that parts could be swapped instantly. A malfunctioning gun could be replaced at an outpost without waiting for a custom build, reducing repair time and increasing combat readiness. Standardization extended to ammunition, using the same 50 cal rounds across multiple platforms, aircraft, vehicles, ships, simplified logistics, reduced distribution errors, and allowed stockpiles to be shared efficiently. On a large scale, this effect multiplied. A facility like Lake City produced billions of rounds per year, enabling each P-47 squadron to carry vast reserves and fire at intensities previously unimaginable. Management of production was supported by a highly trained workforce, including a critical role for women in assembly lines. Productivity relied not only on machines, but on human labor organized for specialization, shortening training time while ensuring quality. Reliability was ensured through strict inspection protocols. The rejection rate of substandard products was kept low but consistent, meaning fewer pieces of equipment were sidelined due to quality issues. Compared to German wartime production, there was a profound ideological difference. American industry moved from manual to semi-automated and fully automated production, applying assembly lines, specialized tools, and statistical quality control. German industry, while skilled and capable of sophisticated design, relied heavily on manual craftsmanship and smaller suppliers, vulnerable to disruption from bombing, resource shortages, and labor constraints. The direct result was a difference in replacement and recovery speed. A heavily damaged P-47 could be rebuilt from existing stockpiles in days, whereas many German aircraft required cannibalization or shipment back to main factories, extending their absence from the air. Production superiority also translated into unit cost reduction and continuous improvement. High output lowered the cost per aircraft, allowing upgrades such as increased ammunition per gun or improved air intake and cockpit design without greatly increasing unit cost. Using the same caliber rounds across multiple combat platforms also increased logistical flexibility. Supply ships, island depots, and forward bases could be replenished with the same items, reducing delays and errors in the supply chain. Strategically, this industrial system created a self-reinforcing cycle. More production, to more stockpiles, to more training, to experienced pilots, to increased combat effectiveness, to justified and expanded production. As a result, it was not just a single aircraft, but an entire industrial-scale war system that could maintain continuous pressure on the enemy and adapt quickly to losses. Germany, despite having large facilities, could not sustain equivalent scale due to multiple factors. Strategic bombing disrupted factories, limited raw materials, dispersed production to avoid destruction, and declining workforce. When production was cut or quality suffered due to material shortages, technical improvements such as larger guns or modified armament configurations could not be implemented at a scale and pace sufficient to alter battlefield outcomes. Another practical consequence of American industrial superiority was the ability to maintain combat reserves. P-47 squadrons and related air units could sustain high ammunition and parts reserves for weeks or even a month without immediate resupply from across the ocean. This enabled prolonged high-tempo operations, creating continuous battlefield pressure that Germany could scarcely counter. Psychologically and in terms of workforce morale, the production model also provided a soft advantage. Millions of factory workers saw their efforts as directly meaningful, boosting motivation and reducing strikes or internal sabotage. On the other side, forced labor under harsh conditions led to lower quality and risk of sabotage. Ultimately, the American production philosophy was not merely about producing large quantities, but about integrating production, design, logistics into a continuously operating system. The P-47 was the tangible symbol of that system, an aircraft designed not only to fight, but to be produced, supplied, repaired, and upgraded at scale, creating a sustainable strategic advantage. Looking at the skies over Europe in 1943-1944, it was clear. The dense presence of high-volume aircraft and unceasing supply transformed individual firepower into collective strength, embodying the essence of industrial advantage, not only winning battles, but rendering the enemy incapable of continuing effective resistance against a comprehensive war machine.
The P-47 is defined not merely by a few technical figures, but by the way those figures combine to create real tactical advantages on the battlefield. Technically, the heart of the Thunderbolt is the Pratt & Whitney R2800 Double Wasp, a two-row radial engine with initial output around 2,000 HP, later pushed to roughly 2,300 HP in improved versions, coupled with a turbo-supercharger mounted in the rear fuselage. This engineering solution allowed the P-47 to maintain high power at altitude, 20,000 to 30,000 feet,
where many European engines began to lose performance. Although the turbo system was heavy, recorded at several hundred kilograms, it gave the P-47 a crucial advantage: the ability to hold speed and climb effectively at high altitude, enabling attacks from above and rapid withdrawal while still maintaining aircraft energy. The airframe itself was built to withstand impact and damage: a wide fuselage, sturdy wings, and thicker metal surfaces than many lighter opponents, turning the Thunderbolt into a tanker that could absorb numerous bullet holes and still complete its mission or return the pilot to base. Many accounts record P-47s coming back riddled with holes while the engines still ran and controls remained usable, a factor that not only saved pilots' lives but also reduced replacement time for squadrons. In terms of firepower, the 8 Browning .5 cal Mark II machine guns, 4 per wing, were not merely an impressive number on paper, but a highly reliable weapon system. The M2s were produced for high parts interchangeability, fed by disintegrating link belt systems that allowed continuous fire without jams, with standard ammunition loads initially about 350 rounds per gun, later increased to around 425 rounds per gun or more, depending on the variant. Convergence was typically set near 250 yards to create an optimal dense zone of fire when aircraft fired in concert. Tactically, this turned the P-47 into more of a weapons platform than a classic dogfight machine. Instead of needing the perfect angle and extremely close range for a few 20mm rounds to be decisive, a P-47 pilot could open up from a comparatively safer distance and rely on massed ammunition and shot dispersion to inflict crippling damage. The aerodynamics and structure enabled the P-47 to execute boom and zoom tactics effectively: climb high, dive steeply to convert potential energy into speed, strike with high speed, and then escape before the enemy could respond with tight turning. Retained energy allowed the aircraft to zoom back up to altitude or set up for another pass. The aircraft's massiveness also aided firing stability. A heavy fuselage and wings provided a firmer platform, reducing oscillation during firing and keeping groupings tighter compared to lighter planes that tended to shudder more under recoil. On fire control, the P-47 used traditional aiming points taught in training, and later benefited from technical updates like improved gun sights, helping pilots exploit the advantage of large ammunition loads. One inseparable component of tactical effectiveness was range. Early P-47s were limited compared with long-range escort requirements, forcing them to operate mainly within shorter protective zones. However, measures such as 75-gallon drop tanks and larger tanks gradually extended escort range by hundreds of miles, and later versions like the P-47N for the Pacific featured increased internal fuel capacity to meet long-range needs. In combat, these technical traits translated into clear tactics. P-47 formations usually retained altitude superiority to enable dives of fire on opponents, forming boxes or fans, including Zemke's fan, a dispersal style that created overlapping fire streams to effectively cut off enemy approach vectors. Formation structure and training allowed American pilots to coordinate to maximize the combined effect of 8 guns firing simultaneously. A direct consequence of the P-47's structure and firepower was a change in how opponents, especially FW-199 and BF-109 pilots, had to approach. Traditional pursuit attacks based on short, precise bursts at very close range became much riskier when facing wide coverage zones and the P-47's capacity for sustained fire. The Luftwaffe therefore developed new tactics such as low-level attacks that exploited the FW-199's roll rate and low-altitude maneuverability, or delaying engagement until P-47s left the area before striking bomber formations. But those options carried their own drawbacks. Low-level attacks surrendered energy advantage and made attackers vulnerable to Allied ground attack countermeasures.
The P-47 also proved versatile in ground attack roles. Its rugged airframe could better withstand small arms and flak fire, allowing it to approach ground targets on shallow dives and use guns, rockets, and bombs against vehicles, cranes, and supply depots. Ground attack runs typically used a diving angle around 30 degrees, open fire from distance, and then zoom away, exploiting diving speed and ammunition mass to inflict wide damage. Finally, the design emphasis on components, engine, and guns that were quick to maintain and easily replaceable produced a continuous tactical benefit. Damaged aircraft could return to operations faster, sustaining aerial density and pressure. Combined with strong training pipelines and logistical support, the P-47's technical features enabled it not only to win individual dogfights, but to transform the air battlefield into an environment where the opponent's tactical options were constrained. The most effective countermeasures became those that reacted to the kill zone the Thunderbolt generated.
The P-47 didn't just change the game in the skies. It transformed how ground campaigns were conducted by combining potent individual firepower with large-scale deployment and durability. When groups of Thunderbolts filled the skies, they didn't merely hunt enemy aircraft. They became tools of suppression and infrastructure destruction, paralyzing German logistics and strategic movement. At the campaign level, this role manifested in two mutually reinforcing aspects: bomber escort and interdiction attacks, both directly constraining the enemy's combat and maneuver capabilities. As P-47s escorted bomber formations deep into enemy territory during 1943 to 1944, they sharply reduced bomber losses by acting as a shield of fire around the formation. Beyond that, they conducted large-scale ground attacks, destroying trains, convoys, airfields, depots, and military targets such as command centers, artillery emplacements, and supply columns. This effectiveness relied on the combination of main guns with the ability to carry rockets, small bombs, and demolition bombs. In a single pass, a P-47 could unleash hundreds of .50 cal rounds into a convoy, fire rockets to split rail cars, and drop bombs to destroy tracks or bridges. Repeated across hundreds of aircraft, the cumulative strategic effect far exceeded that of any single raid. Strategically, sustained damage to railways and transportation slowed or blocked troop movements and the supply of ammunition, fuel, and reserves, leaving German units unable to operate cohesively. When supply lines were disrupted, both offensive and defensive operations weakened due to lack of ammo, fuel, or replacement parts. And in this context, Allied battlefield advantage expanded rapidly, without the need for direct attacks on every front. P-47s executed interdiction in a strike fast, withdraw fast, repeat manner, diving to attack, delivering concentrated firepower, then zooming back up or shifting to another target, a method that exploited airframe and engine strengths while minimizing the risk from flak. The result: daytime traffic across many areas of Germany suffered crippling disruption. Trains avoided daytime movement, supply depots limited activity, and vital routes became unsafe for strategic transport. Contemporary reports and unit diaries confirm this. Large reductions in operational locomotives, reduced flow of goods, and longer wait times directly reduced the enemy's ability to respond rapidly to Allied attacks. P-47s didn't stop at railways. They targeted airfields and enemy squadrons as well. Focused attacks on parked aircraft, fuel depots, hangars, and maintenance facilities rendered many planes unable to fly or destroyed them before they could operate. Continuous .50 cal fire allowed P-47s to incinerate aircraft fuselages, fuel stocks, and infrastructure, while rockets and specialized bombs demolished critical bridges and track sections.
These attacks deprived the Luftwaffe of launch bases in key areas, reduced sortie rates, and forced Germany to disperse forces to protect vital sites, weakening overall operational efficiency. During campaigns like D-Day, the P-47's ground attack role was especially evident. Thunderbolts not only secured the skies for the landing forces, but swept away vehicles, destroyed munitions depots, and neutralized ground responses, directly contributing to the success of the landings by limiting enemy movement and counterattacks in the critical early hours. Remarkably, the P-47 carried out these missions with high frequency and endurance. Rugged, easy to maintain, and quick to return to action thanks to available spare parts. This allowed successive attack waves to continue over days or weeks, maintaining pressure without waiting for lengthy re-equipping. Coupled with robust rear-area logistics, ample ammunition and parts reserves, and continuous supply convoys, Thunderbolt groups could operate at high tempo almost continuously, wearing down Germany's war economy and combat capability. Strategically, this was crucial. Rather than a series of isolated victories, the P-47 functioned as a continuous pressure instrument, eroding enemy capacity until they could no longer organize effective counterattacks. Moreover, the psychological impact of relentless harassment on the ground was significant. Soldiers, drivers, and commanders became fatigued and demoralized as transport routes were constantly threatened and moving convoys became vulnerable targets. The persistent presence of Thunderbolts in the sky created a danger zone that forced normal German operations to avoid certain areas, slowing all activity and granting the Allies critical time. Overall, the P-47's strategic role, combining air firepower with ground attack interdiction, made it a logistics eradicating weapon, one that didn't merely destroy physical targets, but weakened the enemy's ability to organize, move, and sustain combat.
The legacy of the P-47 Thunderbolt extends far beyond World War II. Not only because of the tactical and strategic achievements it delivered, but also for how it shaped thinking, industrial capacity, and modern aircraft design. On the European battlefield, the Thunderbolt demonstrated that superior firepower combined with durability, reasonable range, and mechanical reliability could compensate for the lack of agility compared to lighter enemy aircraft. However, the P-47's success was not solely a matter of technical features. It stemmed directly from a meticulously planned production and logistics system based on the U.S. industrial philosophy: mass production, high standardization, easy maintenance, and continuous supply. The production of 15,683 P-47s, over 400 aircraft per month from multiple factories, combined with billions of rounds of ammunition annually, vividly illustrated industrial power that Germany could not match, despite their pilots' skill and advanced technology. Tactically, the P-47 established a new model for using heavy single-engine fighters as multi-role platforms, engaging in air-to-air combat, suppressing ground targets, escorting bombers, and paving the way for integrated air campaign strategies. Boom and zoom tactics and the use of overwhelming firepower became a standard for U.S. squadrons, and later influenced the development of tactics from modern multi-role fighters. Moreover, the P-47's effectiveness in ground attack roles underscored the importance of interdiction, destroying enemy infrastructure, depots, and transportation networks as an essential component of modern warfare. Industrially, the P-47 became a symbol of industrial democracy.
a weapon that not only determined battlefield outcomes, but also reflected an entire society's ability to organize production, manage manpower, and maintain quality at high volume. Even when compared with later jet aircraft, many principles established by the P-47 persisted: standardization, rapid maintenance, integrated logistics, and strong, deployable firepower. When West Germany rebuilt its air force in the 1950s, they studied and adopted lessons from the P-47 in design, training, and operational doctrine, demonstrating that the Thunderbolt's strategic legacy extended beyond its initial conflicts. The P-47 also left a lasting mark on weapons development and aerial warfare philosophy. The concepts of firepower dominance and numerical superiority influenced the design of modern multi-role fighters, large-caliber rotary cannons, and the relationship between defense industry capacity and tactics. Lessons from the P-47 regarding the coordination of production, training, and operations remain relevant for building strong, flexible, and resilient air forces. Additionally, the cultural and psychological impact of the P-47, from the distinctive roar of its dive to the confidence it inspired in U.S. pilots versus the fear and resource limitations faced by German pilots, underscored the power of a strategy that combined material, technical, and combat spirit. Ultimately, the P-47 was more than an aircraft. It embodied a comprehensive philosophy of modern warfare: firepower, durability, industrial scale, logistics, and coordinated training. Equipped with 8.50 cal machine guns and millions of rounds of ammunition, P-47s represented American industrial might, enabling victories in the air and on the ground, and laying the foundation for future generations of combat aircraft. From shaping modern tactics to proving that industrial capacity and societal organization could change the course of war, the Thunderbolt vividly demonstrated how the combination of firepower and industrial capacity could alter history. Its legacy continues to resonate in modern Air Force design, training, and strategic thinking, serving as a model for multi-role fighters and a philosophy of warfare based on both quantitative and qualitative superiority. A lesson any Air Force must embrace to remain viable in the 21st century.